By the year 2050, the population of Africa will have doubled. 1 in 4 people on Earth will be African at that point. Now, this is both really exciting and daunting all at once. It's really exciting because for the first time in the modern era, there'll be enough Africans on the Earth to bully everybody else. I'm only kidding. But it's daunting because we're going to have economies that can sustain this population growth, and many of the people are going to be very young. Now, most governments in Africa have a plan for this economic growth. In Kenya, we call ours Vision 2030, and they're all predicated on industrialization. The thing is, though, that the world is going through the 4th industrial revolution right now, which means that there's a merger of the physical, cyber, and biological worlds. It means that because of massive interconnectivity and the availability of artificial intelligence and robotics, many of the jobs that we know and are used to right now won't exist in the future. So the challenge is a lot greater in many ways than it even was when Asia was industrializing, for example. To add to this, one of the kinds of person that you need for industrialization is an engineer, and they're really in short supply on the continent. If you compare, for example, the number of engineers that those same Asian countries had a couple of decades ago when they were industrializing, we fall far short. And I've taught for a while, and many of the students who are studying engineering end up actually working in auditing firms and banks, and many of them spend half their time doing accounting and so on as they're preparing. Now, I was fortunate enough to do my undergrad and postgrad education in the UK and the US, in countries, environments where there was all the equipment that you required, all the sophistication in the systems. And then I worked for about 3 years in Japan doing R&D for a large firm. And so I was very used to having good equipment and went back home and joined the Faculty of Engineering at the University of Nairobi, wanting to contribute and be on the continent. And I quickly found I was really quite useless because there wasn't all the equipment that I'd become accustomed to available. And I was teaching students who I would find very bright ideas in their minds, and they'd be presenting things that I knew if only we had sufficient equipment, they'd be able to really contribute to the challenge of industrialization. So I kind of had to change hats and became quite entrepreneurial and started looking for money to buy the equipment that we required. And I heard about a concept out of MIT called the Fab Labs. These are digital fabrication labs that allow, in a rather small space with not very expensive equipment, people to have access to these tools to be able to make almost anything, as the slogan goes. And so I was able to convince a government official to buy one of these for the university where I was teaching. And immediately we had wonderful results. We saw all kinds of innovations coming through. And for the first time in this context at the university, students from different disciplines were doing, engineering students that is, were doing their lab and practical exercises together in the same space. Normally they'd be siloed. And not just that, but students who weren't engineers at all were also working in the same space. And non-students, people who had nothing to do with the university, were also coming into this space. So you had this rich mix of people who think differently from one another, and this always is really good for innovation. So I was really proud of what we were seeing happening. So you can imagine my surprise when one day the Dean of Engineering came and said to me, Kamau, the students who spend most of the time in the Fab Lab are failing their exams. I said, what do you mean? And I looked into it, and he was right. And the reason they were failing is that they'd honed their skills so well in certain things that they were going out into the city and offering services for money. So they were making money. And they therefore weren't focusing on their studies. And I thought, what a good problem to have. Don't quote me on that, I'm an academician. So we needed to scale this, and at the university things were a bit too bureaucratic. And so I moved out and I hooked up with people who in Nairobi were providing spaces for IT experts to share fast internet and things like that. And some of these spaces are really quite famous. They've made Kenya famous for IT. And together we set up a space which we're setting up right now. We've moved from where we were. We're in a much larger space, and we're sort of making available a wide range of equipment, including the digital fabrication tools that I mentioned and analog tools, to anybody really on a membership basis. It's a bit like a gym. So you come in, you pay, you get taught how to use the equipment, and then you're set free to innovate and do whatever it is that you want, and you don't have to be an engineer necessarily. And some of the people in the space are setting up a small company. They just need a space at a desk, and so we provide that at a fee. and others take up bigger spaces and are able to set up their offices. They're further along. Maybe they've got a company that's been running for a certain period of time. And so we're able to accommodate all of this in an innovation space that is really quite active. What you're seeing in this image over here is Douglas. And Douglas is an electrical engineer, one of the people who was really active in the Fab Lab. I think he passed his exams. Pretty sure he did. And the image on the top left is a copper sheet. And he designed a circuit that a client came to him and said, I need this circuit for a pay-as-you-go system. And so this is a model for business that's made accessibility to goods and service for very poor people really much easier because they're able to pay a little bit, like $1 a day, for example, for a specific service. And so this company wanted to pilot a new idea that they have. And so they just need 50 circuits. So they hired him to make them. And what you're seeing him doing there is he's able to design on the computer what the circuit will be and then transfer it through an etching process, that's the image on the top right, and then populate the board using this robot. And so what would normally take him maybe a day or something to solder by hand, he can do in a few minutes using this machine. So he was able to complete the entire order within Gearbox. And this is really important because if it wasn't for what we've provided right now, he would have had to have hired a company in China to do this. And because it's such a small order, it would have taken a long time. It would be a small company because big companies wouldn't take small orders. And even then, if they got a bigger order, they'd bump him off in favor of that. And there's language problems and so on. So being able to do it in country is really very important. And of course, piloting as a phase within the progress of a business idea is extremely important because you can go back and make corrections and so on. In this image, thank you. In this image here on the top left, what you're looking at is a 3D render of a digital fabrication machine. In this instance, it doubles as a plasma cutter and also a wood router. And so the plasma cutter makes possible the cutting of plate and sheet metal, and basically you make a design on the computer and send it over to the machine, and then very quickly and precisely it's able to cut the shapes that you want. But in this particular machine, you can also change the plasma cutter and put on a spindle, and then you can carve wood as well. So this was designed by my head of engineering. His name is Washida. And when I hired him about 2 years ago, I asked him, just give me 2 years, and by the time you've trained a lot of people so that we have good staff under you, then you can move out and become a good story for our space. And that's exactly what's just happened. He's got two types of customers. The higher tier customer is a company that's actually using his machine to cut sheet metal for Isuzu truck fabrication in Nairobi, which is being done by General Motors. So we're really proud to be able to say that we have an original equipment manufacturer in Nairobi that's provided what's effectively an industrial robot to supply parts for General Motors. Now, this is really important. And it's really important because the population growth being what it is, a lot of very large companies are looking very closely at the market that's developing in Africa. So in Kenya right now, we have Volkswagen, Peugeot, Renault, we have Mercedes doing lorries, and we've also got Toyota. They've been there a long time. And these are all manufacturers planning to assemble vehicles and in the future to manufacture in the country. Many of them are planning to train lots of people that they'd hire, and that's really important for the economy. But when the magic really happens, when these companies begin to buy their parts that they need for the vehicles from local companies. So supply chain development is something that's very important for us to be able to pivot and to have very productive economies, and that's something we're focused on at our space. This other image shows another class of customer that he has. On the top left, you have these people who are actually using very crude tools to work metal and wood. And Kenya has a population of about 44 million people. The workforce is about 13 million, and about 80 to 90% of those are in the informal sector. And what you're seeing in the image on the top left over there is very typical of semi-skilled artisans who are making products for the marketplace that are really crude. Their production rate is really very slow. The quality of the product isn't high. And so we've teamed Washida up with a bank, and the bank is paying him to train people from this sector on how to use this industrial robot. And the result is that some of them are going to be able to get loans to buy the machine for themselves. Others will be able to go to centers where they can carry their material, get the design done, and take the materials back that have been made really, really fast and assemble them in their own spaces. So somebody making a gate, for example, out of metal may take a week to make just one gate. But with this machine, they might make 10 in a day. So the productivity of a large swathe of our population should be able to jump by a quantum amount quite significantly because of this kind of machine. And that's what we're at the beginning of. So this is really very exciting. This is another person who uses our space. Her name is Esther. She's in her mid-20s, and she came in very passionate about a problem that she explained. She said that school days are missed every month by young girls because of their menstrual cycle, and they're not able to buy a sanitary towel. And the reason that she described was that the manufacturers package these in bundles of 7 to 10. And breaking it down is unhygienic at the retail level, and packaging each one of them is too expensive. So she thought up an idea which is brilliant, it's simple. Why don't we just use vending machines? And she, in a very clean environment, can break down the bundles and fill up the vending machines, and then girls can buy these sanitary towels in the privacy of a toilet, in a public space, in a school, and so on. And she was able to pilot this, and it worked really very well. And she's been able to sort of get the bugs out and so on. So the significance here is that the piloting process is possible. She's not an engineer. She was able to engage people in our space to be able to help her to do this. And she's off and running now with a business accelerator. So we expect to see great results. In this image, you're looking at the result of a master's project that was done at University of Nairobi by Tony Nyaga, an engineering student. And he just integrated a solar cell into a roof tile and decided to make it a business. And he joined up with his sister, who is an architect, and they have this business, and they come and present the roof tile to a person who's doing development and say, you can take this and buy it for the cost of just the roof tile without the solar. So they're giving it at a discount, and then they'll build them using the Internet of Things over time, and they'll pay about a third of what the utility charges for the electricity, and they can sell the excess back to the grid. And so they'll make their money over time. And they've been able to do quite a few installments. We were very proud to be able to show this to somebody kind of famous, as you can see there. And this other famous guy actually presented the same idea, but as far as we're concerned, it was after us. So, so in closing, going forward, of course, being able to prototype and do low manufacturing in this kind of a setting is very important for the industrialization process. But we're also taking advantage of a lot of new ways of doing things. The open source movement, distributed manufacturing, circular production, it's all very important for not just industrializing and being able to meet people's needs, but also making sure that the environment is taken care of. We're also really very interested in culture. We have lots of discussions in our space around who we were as Africans, who we are today, and who we want to be, vis-a-vis things like consumerism and ethnicity and corruption and so on. So we see ourselves as adding value to people by teaching them to add value to things or materials so that they can build things that matter. Thank you very much for your attention. Thank you.